number 4. Coming to the syllabus which you have in your unit number 4 has 3 topics. That is, one is gears, another one is belts, and another one is gear trend. So these are the 3 topics which you have in unit number 4. So in each class I'll be taking one topic. So for today's class, which I'm starting now, I'll start with the introduction of about the unit, as well as I'll go through the topic of first one in unit number 4, that is gear drives, and then next tomorrow's class I'll go with the another topic, gear trends. Another session I'll go with the belts. Okay, so by this we will complete unit number 4. Numerical solutions I'll do separate video. So I'll also post which and what you have more weightage of your questions, as well as what are the important questions which you can expect for the exam. Then after this, in the next week, I'll go with unit number 5. Okay, so as of now I will start with the gear drives. That is your topic number 1 in unit number 4. So in this we are going to deal with the topics. The contents is like mechanical drives. In the selection of mechanical drives, gates classification, gates advantages and limitations, and gear terms and definitions, and spur gears, helical gates, and bevel gates. So these are the topics which we'll learn in unit number 4, or the first topic of gear drives. So let us start with the first one, with the mechanical drives. So as I told you in this earlier, as your topic consists of 3 subtopics in mechanical gear drives. This whole unit we generally we subdivide, or we name it as mechanical drives. So in this mechanical drives consist of 3 topics that we'll learn individually one after the one. So okay, so let's start first with what is a mechanical drive. Mechanical drive is nothing but belt, chain, and gear drives are often called as mechanical drives. Okay, so in this, if you define a mechanical drive, what is a mechanical drive? It is defined as a mechanism in which it is intended to transmit mechanical power over a certain distance, usually involving a change in speed and torque. See, coming to this, if suppose if there is any of your component or a machine which is present over one side, and if you want to transmit our power from one end to the other end, okay, if you want to transfer power from one end to other end, you use shafts. Okay, but is that speed varying, or is the speed constant? That is one important factor. And also, in apart from your speed, there is another factor, which is torque. Is your torque varying, or it is uniform? Suppose if it is uniform, then generally you'll go with your shafts and all this in between, and we also go with your couplings. There are different power transmissions, but in general, if your speed is varying and if your torque is varying, then if you want to transfer your power from one end to other by variation of these factors, then you will go with a mechanical drive. So in this mechanical drive, you have certain applications in your mechanical drive as belts, chains, and gear drives. These are the 3 units which comes under a mechanical drive. Hope this I'm clear with this. Next is mechanical drive. Why it is required? So it is basically required when you have between a prime mover, such as like electrical motor and a part of operating machines. Suppose if you have a machine, generally your machine works with the help of a motor. When you are transferring your power from one end to the other with the help of this, so in this requirement of your prime mover, there will be a mechanical drive in between. Either it can be a chain, or it can be a belt, or it can be a gear drives, or it can be combination of 3 to transfer your power in a prime movers. Maybe an example with a motor operating in a machine, and it could be any kind of machine. So again, which I told you earlier, these mechanical drives are classified into 2. One is the mechanical drives that transmit power by means of friction. When you are transferring the power, if it is done with the help of friction, then it comes under an example of belts and rope drives. Belts and rope drives comes under a power transmission with help of a friction. And there is another mechanical drive that transmits your power by means of engagement in between. That is nothing but your chain drives and gear drives. Okay, belts and rope drives and all this comes under an example where you can observe any kind of machine which has been transferring your power with the help of your friction. Best example is when you go with any kind of what do you call this vegetable, what do you call your in your home appliances market, which you go with your machines where you can have your wheat floors, all these things where you use a machine. మనం తెలుగులో అంటాం కదా గిర్ని గిర్ని అంటాం కదా, దాంట్లో if you use a machine which has your belts, which is if you are transmitting your power from one end to other, that is basically example of a V belt. Okay, so there are different belts in that. So about the belts in detail we'll go with another session. So if anything which is done with an engagement, suppose if you are riding a bicycle, that is usually done with the help of your chain drive, or maybe some motorcycles also usually done with the help of your chain drive. All your motorcycles comes under an example of a chain drive in which engagement is there in between to transfer your power from one end to other end. And gate drives, all your automobiles where if you want to vary your torque, everything is basically done with help of your gate drives. Where you want to increase your torque, whether you want to decrease your torque, everything is done with the help of your gate drives. Is the best example of that. Not only in your automobiles, anywhere in your any machine you want to vary your torque, that is basically done with the help of your gate drives. Okay, so this is about your mechanical drives in which you have. So first we'll start the first topic, in that is the gate drives, and next chain drives is not a part of your syllabus. Belts is a part of your syllabus that we'll go through the next, and also there is a gate trains extension to the gate drives that we'll do to the next class. Now selection of your mechanical drive. Now as you told me, like there are these many number of drives in a mechanical one. So how do you select it? So what could be the criteria in selecting? So these are the factors in which if you want to select that, whether in this three you have your belts, and whether you have your gears, and whether you have your what you call chains, how do you select this? In what way you need to go? That depends upon your number of factors, which the first one is if you want to go with the belts, is basically suitable when you have your long distances, long center distances. What your center distance, all everything will go through definition next. Okay, so if you want to go with your when there is transmission of your power from one end to the other, it is a longer distance, then you'll go with the flat belts or maybe a roller chains. Or when the power transmission is between a short distance from maybe about a meter or half a meter in that, so you go with the V belts. Suppose if your center distance is very short between your two shafts, if you want to transfer your power, that will be basically a gate drives. Okay, so wherever you are transferring a power, that depends upon your distance of your transmission. If it is too short, then you'll go with the gate drives. If it is a bit short, then you'll go with V belts. Then if it is a longer one, then you'll go with the flat belts or maybe a roller chains. So this is a criteria of selection when you go with the mechanical drives. Okay, and next further if you move on, let us understand first what is a gear. We'll define it, and next we'll go with the classification of gear. So in this, a gear can be defined in n number of ways. Anything which is used for your power transmission or variation of your torque within a small short distance, we generally define it as gear, in a simple way of you defining. So if you go through that, a gear or a toothed wheel is a rotating machine part which is cut teeth which meshes with another tooth gear or transmit power or torque. Gear devices can change the speed, torque, and direction of your source. As if you go through any of your automobiles, generally if you observe, when you are transferring your power from one end to the other, which is at the engine which has been produced the power, if you want to transmit onto your rear wheels, in between there is a clutch and gearbox. In that the power is being varied and then it has been transferred onto your propeller shaft. So in that, if you have your gears, if you observe, there will be different sizes of gears: when small gear, medium gear, long gear, which we say it as a pinion gear. Another one is toothed gear. Another one we say it as a planet gear, ring gear, sun gear. Different types of gears based on the sizes. That depends upon your velocity ratio, which gears to be used, either the small one or the greater one. That we'll go through what is a velocity ratio, all these definitions in the later one. So in this, that gears has a small kinds of tooths which is mesh with one gear to the other one. If you want to transmit a power, there one small gear will be meshed in with another gear, which cannot be of the same size. It will be either as a shorter one, either it will be a longer one of that gear to transmit, which comes in mesh. And by that, what is you are going to have is one will be a driving gear, another one will be a driven gear. So by this, you will have the variation of torque, variation of speed, and direction of your power source. So that is about your gear. And next, these gear is also defined as a toothed wheel or multi-boloid cams which transmit power and motion from one shaft to the another one by means of engagement of teeth. The similar definition which I learned before. If you want to transmit from one end to the other one, which of your similar teeth or maybe a number of teeth may be different from one gear to the other one. By that, in contact or engagement, the power will be transmitted. So in this, you have different types of gears. So in that you have spur gear, helical gear, bevel gear, and worm gear. So out of this four, three are in a part of your syllabus, and another one which is not a part of your syllabus. Spur gear, helical gears, and bevel gears is part of your syllabus. Worm gears is not listed in your syllabus. So we'll go through these three gears, which is of spur gears, helical gears, and bevel gears. So in this part of this, only a theory questions you can expect in the exam. There is no problematic. If so, there is a problematic. There will be a small shorter question which could be expected. I'll tell you at the later case what is a model which you can expect. This is about your gear and the classification. Next, we'll move on to the other one. Now coming to the next one is advantages of your gear drives. Why do you select only gear drives? As a part of your mechanical drives, just before what we have learned was we have gear drives, chain drives, belts. So out of this, why do you select only gear drives? First, if you want to go to the gear drives, the first and foremost important thing is the distance should be shorter. So if your distance is shorter in your power transmission, then why do you only select the gear drives? For that, which I have listed some of the advantages, such a way like it is a positive drive where the velocity ratio will remain constant. One of that is your velocity ratio. It remains constant. What is a velocity ratio and all those things? We'll learn in the next after the definitions. Center distance also we'll go through. The center distance between the two shafts is relatively small and results in a compact construction, which I told you earlier is if you have your smaller distance, then you transmit. Even your smaller distance, it is very compact. That is very simple. If you are which can fit enough within a small sizes, okay, then it can transmit very large power. The power transmission apart from your belts or maybe your chain drives, if you compare, the power transmission will be larger, efficiency will be larger when you compare it with the other drives. So it can transmit motion at very low velocity, which is not possible with your belt drives, because belt drives are usually used for longer transmission of your powers, where you can usually go with a shorter one with a low velocity ratio also for the gate drives. But if you want to go with the belts, usually it should have the higher velocity ratio. Next, which I told you earlier, efficiency of your gate drives is very higher. It can go up to 99% also. Out of all this, Spur Gears which has most efficient one. Okay, provision can be made in the gearbox for gear shifting or changing the velocity ratio with a wide range. Usually for all your automobiles, you have a gearbox. So in that you have different gears. So in that the provision of this, all these gears are provided in the gearbox. Okay, this is about your advantages of your gear drives. Okay, next we move on to the other one, which is limitations. Suppose next before which you have gone through was your advantages in choosing your gate drive. So what is the limitations? For everything there will be a pros and cons. Just before you have learned about the advantage, now we'll go through the limitation. What is the limitation of this? Usually gate drives are very costly because what do you call the shape may be a little complicated because you make number of teeth in that to have your mesh, and production of that gates is also very bit costlier one. That is the case, the gates or gate drives are a bit costlier when you compare with your chain drives or maybe your belts. And maintenance cost is also obviously higher because you have your contact between the two gates continuously, then lubrication is required and changing of that. Obviously the maintenance cost will be higher for your gate drives. And next, manufacturing process for the gate drives are complicated, obviously, which I told you. Maybe if you go with the bevel gates or maybe different kinds of gates, that manufacturing process for that it is a little bit difficult. What is the manufacturing process which we generally use is hobbing? That we learn about the manufacturing process. How do you do all these things in unit number 5? Okay, now this gate drives requires a careful attention. So it is complicated because we require lubrication, we require cleanliness. This kind of maintenance is required, so continuous observation is required. Next, they also require precise alignment of your shaft because it is very compact. You have your shaft, your grades, everything in a compact one. So alignment is little, you should be very careful in that. So these are all the limitations when you go with a gate drives. Okay, hope I'm clear with this. Shall we continue with the next topic, guys? Is everyone listening? Yeah, yeah.
Yes,
Next, gear terms and definition. This was very important one, because short questions which could be expected mostly in case of this topic is from this one which we are going through now. That is the definitions which we have over here is pinion, gear, velocity ratio, pitch circle diameter, base circle. So out of that, first is pinion. Pinion is nothing but a small rotating gear in which it is used to transmit your power to have your constant mesh with the other gear. Next, gear is a bigger one. The larger one we generally say it is a gear, a smaller one which is a pinion one. Okay, so both comes in a contact to transmit your power. Next is, just before I told you what is a velocity ratio and all those things. Velocity ratio. Coming to velocity ratio, it is the ratio of your angular velocity of your driving gear to your angular velocity to your driven gear. That is nothing but it is called as a velocity ratio. It is also nothing but sometimes we say it is speed ratio. So usually if your velocity ratio is also small, we generally go with the gear drives. But in case of belts, it should be higher enough. It cannot be with a smaller one, because your driving one should be higher than your driven one. Here, sometimes driving one also, if it is in a running in a slower speeds, your velocity ratio is low. You can also go with the gear drives one. Okay. Next is your pitch circle one. I'll show you a figure which is related to the pitch circle diameter, base circle, and all those things. First, we'll go through the definition, and then I'll show you a figure related to this. Pitch circle. Pitch circle is nothing but is a curve which is actually an imaginary one, which is an intersection of your pitch surface of your revolution and a plane of revolution. It is an imaginary circle that rolls without slipping in a pitch circle of a mating gear, which you can observe over a figure over here. So here in a center one, which is nothing but view, which we say it is pitch circle one. So that is an imaginary circle which has been drawn for a gear one. Okay. And next is pitch circle diameter. So this circle diameter, we generally say it as a pitch circle diameter. If you ask the size of a gear, the size of the gear is usually denoted by a pitch circle diameter itself. That is small d. Okay. Next is base circle. Base circle is also another imaginary circle from which the involute curve of a tooth profile is generated. So you observe the figure over here. The center line is nothing but your pitch circle one, and the other one apart from that, which is near to the pitch circle, is nothing but we say it as a base circle, which actually provides you an involute for your gear tooth. That is, we generally say it as a base circle. And next you have another one is addendum circle. This is all the circles which you are actually learning as an imaginary circles. Okay, so it is also an imaginary circle that borders the top of a gear tooth in a cross section. If you observe the figure over here, the addendum circle is a top one which borders your pitch circle one of your teeth, which you have. You can observe the figure over there. The teeth, upon the teeth one which you have, that circle is nothing but we say it as an addendum circle. Okay. And next is dedendum circle. Dedendum circle is also an imaginary circle that bottoms bottom of your space between your tooths of a cross section. Anything, if you in center line one you have your pitch circle and base circle, and the top you have addendum and the bottom you have dedendum. These are the definitions of different circles and which are imaginary. Next is dedendum. We have learned about the addendum and dedendum circles. Next is dedendum. This dedendum is nothing but it is the radial distance between the pitch and the dedendum circle. What does the dedendum circle indicate? This actually indicates the depth of the tooth below the pitch circle. You observe the figure just before. What is that? It is your radial distance between your addendum circle to the pitch one. So this is nothing but it indicates the depth of the tooth. This dedendum one. Okay. And next is you have your dedendum one. It is also your radial distance between your pitch and the dedendum circle. Just before was the radial distance between the addendum circle. This is the radial distance between your dedendum circle. This dedendum circle indicates the depth of the tooth below the pitch circle. That addendum circle indicates the height. Sorry, it indicates the height of the tooth above the pitch circle. Dedendum indicates the depth of the tooth below the pitch circle. Anything the addendum is top, above, and dedendum is below. So dedendum indicates the depth of the tooth and addendum indicates the height of the tooth. Okay. And next, clearance. What is the clearance? Clearance is the amount by which dedendum of the given gear exceeds the addendum of its mating tooth. Generally we say it as a clearance. So if it is exceeding the addendum, then we say it as a clearance. So clearance, it is indicated over there. You can observe the figure where if it is exceeding the addendum one, that distance between that split circle one below that, if you understand the working depth and of the figure, here you have your clearance. Here you have your clearance in between. I cannot show you. Here it is a clearance. So this addendum is above. This is your height of one, and this is your pitch circle, base circle, and below is your addendum. This is your depth. So this is your working depth, and this is your wall depth. So which includes your clearance. It comes under wall depth, which includes only the distance of your addendum one, which we say it as a working depth. And anything the distance between these two, we generally say it as a tooth space. And anything, if you have your what do you call this tooths, this is generally indicates the distance between this is nothing but your tooth thickness. And this pitch circle, the same imaginary one. Okay, and next we move on the center distance. Just before we have learned about the velocity ratio, and another important one is center distance. The center distance is the distance between the centers of pitch circle of mating gates. Centers of pitch circle of your mating gates. It is also distance between your center of base circles of your mating gates. So if you observe this, where you have your distance between your mating gates. So this, if you have another gear which is coming in contact with that, so that distance between from one to the other gear of your mating is generally nothing but we say it as a center distance. Okay, hope this definition is clear to you. Next we move on to the another important definition related to that. We say it as circular pitch. So circular pitch is a distance measured along this pitch circle between two similar points of the adjacent teeth. If you go with this, we have number of tooths over here. So to these tooths from one end to the other end distance, that we say it as a pitch, circular pitch, which is denoted by P. This, you have your formula to this, that is pi d by z. D is your distance, where z is a number of teeths. So by this you get a calculation of pitch circle. Sometimes, in the short 2-marker question, they will ask you by giving you a what do you call diameter as well, a pitch circle diameter, as well as they will give you the number of teeths. They will ask you to calculate what is a pitch circular pitch, or maybe a pitch circular one. So in that, you can calculate with the help of this formula which is given over here. Okay, and next is diametrical pitch. Second one is diametrical pitch. So these diametrical pitch is nothing but it is a ratio of number of teeths to pitch circle diameter. So here it is m what do you call P is equal to Z by D dash. Z is your number of teeths and D is your pitch circle diameter. So if these two things is given, diametrical pitch can also be calculated. This is small p, this is capital P. Okay. And next, module is nothing but is a reciprocal or inverse of your diametrical pitch. If your diametrical pitch is known P, then module can be known. Module is nothing but 1 by P, so it is nothing but D dash by Z. So from this, sometimes if your module is given, or if your pitch is given, sometimes your diameter or pitch circle diameter is to be calculated, then you can calculate from this relation where D dash is equal to M into Z. From that relation you can calculate. That is about the model. Once the question has been asked in your OU exam, based on that data which is given, like pitch circle diameter is given as well as your number of teeth is given, they asked you to calculate your module. That numerical solutions I will do it in the next class. Next is center to center distance, which I told you the distance between your two mating gates which you have, that is nothing but we say it as a center distance. So that center to center distance is denoted as A, which you can write it as A is equal to M into ZP plus ZG by 2. So this ZP and ZG will be given, that is your what do you call of your driven and driving gates one, that number of teeths that will be given to you. Okay, based on that, if that is given and module is given, then you can calculate your center to center distance. Okay, and next is gear ratio. Once the question has been asked in your exam also, what is gear ratio? The definition: it is a ratio of number of teeths to the gear on your gear to the number of pinion one. So here where you have your driving gears and another one is driven gears of your, that is your gear to the pinion one. So that ratio is nothing but we say it as a gear ratio. So where if your ZP, that is a pinion one, and G is nothing for your number of teeth for your gear. So that ratio gives you the gear ratio. Okay, so this is about your gear terms, which is very important, which can be expected for your 2 marker questions mainly. Okay, shall we move on to the next one? That is about your gears classification, which I told you earlier. You have 3 different kinds of gears. One is your helical gear, sorry, spur gear. Next is helical gear. Another one is bevel gear. So in this, the first figure which is listed over here is an example of your what do you call spur gear, and this is your about your helical gear, and this is about your bevel gears. First, we'll start with the spur gear. So coming to the spur gear, the spur gear is the most efficient gears when you compare with the other gears, and it is also most commonly used in olden days. Now also in a few cases we use, but there is only one disadvantage with that. Apart from that, you have a lot of advantages when you go with the spur gears. So what is actually a spur gear is nothing but these spur gears are basically used for your power transmission when you have your shaft which is parallel one after the other, which you have your parallel, then you go with your spur gates. These spur gates, you have your teeth which is cut parallel to the axis of your shaft, which is your teeth cut parallel to the axis of your shaft. This is your shaft. This teeth is been cut parallel to the axis of your shaft. Okay, so that is your helical spur gates, and these are parallel to the axis of that. These are used only when shafts are parallel, which I told you earlier. These are only used when your shafts are parallel. These spur gates are imposed radial loads on your shafts. You have different kinds of loads, axial one, radial loads, different kinds of thrusts which can be imposed on your gates. So in this, when you go with your spur gates, based on your application, when you go with the power transmission in a parallel shafts, you have your basically major is radial loads which will be applied on that. There is no thrust force generated in the axial direction because of your shape of your spur gates, which has been onto the axis, parallel one onto the shaft. That's the case. There will be no thrust force generated in your axial direction. Because of this, you have your protection very easier, and this gauge is made to be higher degree of precision because your production is cheaper, because of your not much complicated shape. That's the case. Production is simple, as well as it is mostly used, and your efficiency of your spur gate transmission power is also higher enough. These spur gates has a smaller disadvantage because that is majorly is it makes noise. There is a major problem. In a modern days, when you go with the application of this, you do not go with the spur gates. Okay, next you move on further. You have major advantages as well as disadvantages of your spur gates. One is your advantages. Spur gates have higher power transmission, which I have listed before. They are compact and easy to install because production is simple in construction. That's the case. It is compact and easy to install. They offer constant velocity ratios, just before which you have learned the angular velocity or speed from your driven to the driven gates is nothing but your velocity ratio, which affords your constant velocity ratio, such a like there is no fluctuations in power transmission. And next you have, unlike belt drives, power gates has no slip, where in case of your power transmission, in case of your belt drives, you have major problems with the slip, but the case of this, you do not have any kind of slip. These spur gates are very reliable. It is most efficient one. This can be used to transmit larger amount of power, just before I told you, on order of 50,000 kilowatts also. Basically, if you go with the higher industrial applications, we will be going with the larger one as your spur gates itself. And coming to the disadvantages, spur gauge drives are very costly when you compare with your belt drives. Obviously, when you go with the belt drives, spur gauge, which is very costly, which I told you earlier itself in the starting point, they have limited center distance because they have the contact between one gear to other one is a limited. If you have more contact with that, then friction comes into picture, and then material doesn't transfer your power smooth enough. That's the case. It is a limited center distance you have, and Another one is they have a lot of noise problem, which I told you earlier, and this cannot be used for long distance power transmission. It's a major problem that you go with the belts in that case. Next is gate teeth experiences major kind of stress because the load acting on that is higher enough, the radial loads and maybe axial loads, thrust generations. Apart from this, that's the case, you have higher, larger amounts of stress parts coming into the gears. Okay, these are about the advantages and disadvantages in case of your spur gates. Sometimes I'll ask you in a question in the exam, what are the advantages and disadvantages of spur gates? So in coming to the applications, there are a lot of applications in case of your spur gates. One is power plants, marine engines, mechanical clocks and watches, fuel pumps, washing machine, gear motors, rack and pinion, automobile gates. Was earlier we used to go. Right now we are going with other kinds of gates. Rolling mills, cutting machines, lathe machines. All these kinds of examples are the applications of spur gates itself. Hope I'm clear with this spur gates. Next, I will move on to the other gear, which is helical gear. So coming to the problem with the spur gear is a noise is a major problem, and it only takes the radial load. There is no thrust generation. So that is a major problem. To avoid with that, next we'll go on to the other gates. It's nothing but the helical gates. So these helical gates are used for your power transmission when your shafts are parallel. They have your teeth inclined to the axis. Previously was the axis exactly parallel to the axis of your shaft of your teeth, but here you can have some inclination, maybe 25 degrees to 45 degrees inclination also in that. So these teeth are cut an angle with an axis of your shaft, so that generally this angle we say it as helix angle. So based on this, due to this helix angle, you have your thrust generation also. It takes both your radial as well as your thrust loads. So there is a special kind of gears in which such way like it consists of two helical gears with opposite hand, which generally we say it as a herringbone gear. These are used only when your shafts are majorly parallel. Okay, so next is we have your T's very much longer than when you compare with your spur gears, and the lower when your teeth are very longer, load carrying capacity also very much higher than when you go with the spur gears. And next, compared to spur gate, they have longer contact ratio. Oh, and noise is very low as well as vibrations is very low. That's the case because because of the angle which you have over there in contact with your meeting with the other gears. That is a major advantage which you have. And next, due to the inclination of the teeth, produces your thrust in axial direction. In case of that of your spur gears, you do not have any thrust generation over there, because if you have a higher enough of your thrust generation, then your power production will be higher enough. So these helical gates produces thrust, and therefore it is desirable to use thrust bearings also to absorb this. And next, helical gates are often used in automotive transmission by replacing the spur gates, because when you go with the spur gates application in case of your automobiles, there is a noise problem which is coming into picture all the time when you're changing your gears in your gearbox. If you get noise, that will be a huge problem to you, which is inconvenience. That's the case, you go with the change of your gates from your spur gear to helical gates. Most of the gates which you are using right now in all automobiles is the applications of helical gates itself. Okay, so these are about the helical gates. You can observe the figure over here, which is given in the center one. If you observe the figure of this, where the left one we use about the example of your spur gates, which is exactly parallel to the axis of your shaft, and this is you have the inclination one, which is onto the axis of your shaft, which may be 25 to 45 degrees, whatever the inclination. Due to this, the thrust generation will be there. It takes both kind of loads, and also the power production will be higher enough, as well as the tools will be larger, as well as the power production will be higher enough, and carrying capacity will be higher enough in the helical gates. So when you go on to the advantages of your helical gates, smooth operation is guaranteed because you have your what you call shape of that of your angle inclination. And next is you have your helical gearboxes, and helical gates are long lasting, more suited for application involving higher loads, just before which you have discussed about this point. And it is able to conduct power and motion at right angles or parallel shafts also. Previously was used only for parallel shaft. This can be used for right angles or maybe for a parallel shafts also. Both it can be used for the power transmission. Next, wear and tear is reduced due to the load distribution, because you have your higher loads capacities where uniform distribution of load will be there, more number of tools. That's the case, your wear and tear will be avoided in case of your helical gates. This is about the larger advantages of your helical gates. And next, coming to the applications, you have your printing, earth moving, fertilizers industries, sport, power industries, steel, rolling mills, textile industries, food industries, plastic industries, conveyors, belts, compressor, blowers, oil industry. Huge applications you have of your helical gates. All automobiles right now we are going with all helical gates itself. Okay, so this is about your helical gates. And next, coming to the last one, is your bevel gates. So these bevel gates are the gates where the axis of your two shafts intersects, and the tooth bearings of your gear themselves are conically shaped. Previously was first was exactly parallel, and next was inclined, and next now this is the axis of the two shafts intersects both, which is the 90 degrees one. They have the shape of a truncated cone shape. The size of the gear tools include the thickness as well as height, which decreases towards the apex of the cone. Bevel gates are normally used for shafts which are at right angles exactly to each other. Bevel gates imposes radial as well as thrust loads on the shafts. Bevel gates are most often mounted on shafts that are at 90 degrees apart from the desired to work at other angles as well. Previously, if you go through the figure, if you observe, this is exactly axis parallel to the shafts. Only for a parallel shafts, we'll go with this spur gates. And this is slightly inclined. We'll go with the both right angle one as well as the parallel one. Only herringbones will go with the exactly parallel shafts one. And when you go with the bevel gates, which is exactly, you can go with your right angles one when you have your power transmission, which you have your shape of the tooth which is exactly inverted to each other. That is about your bevel gates. And you have your lot of advantages as well as disadvantages when you go with the bevel gates, where the advantages of this is your operating angle could be changed. If you want to change any kind of angle, you can change with that. But when you go with the what do you call your spur, you do not have any kind of angle. When you go with the helix angle of your helical gates, you usually have about 45 degrees or maybe 50, not more than that, but you can have your 90 degrees and you can change any of the angle over here. Bevel gates could also be made by nylon or plastic or any kind of things. Usually in case of your differential which you have, in case of your automobile, we generally go with the different kinds of gates of your helical as well as bevel gates in that. So in between you have your smaller gates of your differential is nothing but your bevel gear. What is a differential? Differential is used in an automobile at the rear end, where if you want to transmit your power equally to two axles of your shaft of your wheels. Suppose if you have your power transmission more on the right wheel and less on the left wheel, then you have your unbalance and your vehicle will skid and fall. When you take a turn where your outer wheels rotate faster and your inner wheels rotate slower, if your inner wheels rotate faster than your outer wheels, then you have your skidding. So to avoid that, these adjustment of your power is also basically done with the help of your differential. So in that differential we use bevel gates. So manufacturing cost will be less in case of your bevel gates, and sliding friction also will be lower in case of your bevel gates. That is the major advantages which you have with your bevel gates. And next is disadvantages, which is precisely mounted because the size or the compactness of that, and it will be exposed to the higher enough forces. And major disadvantages, the gear ratio is limited over here. If it is less than 5, then only you'll go with the bevel gates. If your gear ratio is higher enough, then you cannot go with the bevel gates. Gear ratio, which is before we are learned, that is a ratio of your number of teeth of your gear to the pinion one, is nothing but we generally say it as a gear ratio. If it is less than 5, then you'll go with the bevel gates. If it is greater than 5, we will not go with the bevel gates. There is another type of the gear apart from this, that is worm gear, where if you have higher gear ratio, higher velocity ratios, then you'll go with the worm gear. That is not a part of your syllabus. So apart from that, the applications of your bevel gates, if you go through, bevel gates are used to transmit the power and motion between your two shafts when the speed and load both are small. And your hypothetical bevel gates are used in various automobile applications such as differential, vehicle differential. Just before I told you the differential, there is an application. And next, bevel gates are also mostly used in marine applications, locomotives, steel sector, defense sector, cooling towers, printing press, and all. Bevel gates are used as a key mechanism of handrails which you have, and next to swaying machines is also used as a spiral bevel gates. So these are the applications of bevel gates. So apart from all these gates, maximum efficiency will be higher in case of your spur gates, and next your helical gates, and next your worm gates, and next is your bevel gates. Okay, most applications right now we generally go with helical gates, and next comes on to your worm gates, and next you have your bevel gates, and next you have your spur gates, because noise is a major problem of your spur gates. So if there is an expected question in the exam, there would be such a way like, what are gears, define a gear and classify the gears with a neat sketch explanation. If it is asked for 2 marks, just you need to define a gear and then classification. If it is asked for 5 marks, you need to explain with each gear. If they ask you for long answer with separately explain with a neat sketch working of spiral gear or maybe a bevel gear individually, then you need to go with this construction, working, as well as advantage, disadvantage, and application. If it is asked for individually for 5 marks, if it is asked for complete 10 marks, you need to list all working, advantage, disadvantage, application, all those things. If individually it has been asked application for 2 marker be 5 marking, you need to list out. Few times it has been asked list out the applications of spur gear or maybe helical and bevel gates. So majorly please go through the applications also. And sometimes they may ask you differentiate between your helical gates and bevel gear, or maybe helical and spur gates, they may ask you difference between that. Okay, hope the session is clear to you. With this, I will stop at this session. Just once we'll go through the questions which has been asked in your previous year of your OU exam about the gears. Short answer question, that is define pitch circle, module, and gear ratio. Just before we all learned, pitch circle is imaginary circle which is drawn in the center. Module, which is a reciprocal of your pitch circle diameter. Gear ratio, ratio of your gear, teeth of your gear to the teeth of your pitch circle. And next, compare 5 spur gates and helical gate application just before which are listed. Please compare with the applications which is listed just before, and this is not a part of your question which is wrongly given over here. Next is distinguish between spur gate and helical gates, same similar one, repeated question. What are applications of bevel gear and helical gates? Just before I listed you the applications. Next, write the applications and classification of gears. If it is asked for 2 marker question, so just write classification like spur gear, helical, and this one, and this are the applications straight away. Next, classification of gates. This is gear, this are spur gear, helical gates, classification. Define pitch, addendum, and module of gear. Just before the same definitions. Addendum, which is the outer one, which is nothing but it indicates your height. Okay, so this are the questions which has been asked in gears from 2009 to 2020 of all your EME exam questions. And next, if you go through the long answer question, only one question has been asked. Let us compare gear drives with your belt drives, where just before which I told you gear drives is usually used where you have your power transmission in a compact one, long, small, shorter distance, where you go with the belt drives at the longer distance one, where the power transmission is higher enough in case of your gear drives, where it is less in case of belt drives, and efficiency is higher in gear drives, less in belt drives. There is no slip in gear drives, there is slip in belt drives. These are all the different classifications you can list out in case of your gears. Okay, so with this I will stop the session over here. Hope everything is clear to you for everyone. Next class we'll move on to the other one, which is the topic is belts or gear ratios.